Hey, this is going to be review of equations. So this is the very first lesson. So your notes should look like this. So we're going to start with what does it mean to be a solution to a math problem? And all a solution does is it when you substitute it in, it makes a true math statement. So like 2 equals 2 or 2 plus 2 equals 4. Those are true math statements. So you can check by substituting the solution in and making sure it makes a true math statement, or you can solve it in order to, it's like if you had, like on example 1, if you said x equals 4, you could solve it and make sure you got the same thing, and then you could see if that was true, or if it said x equals 4, then you would substitute that in and see if it was true. So to solve the first one, hopefully, and many of you can do this in your head, I am going to show my work just as we're getting started. But you're going to start by adding 8 to both sides, which would be 63, divide by -9, and we get a -7 for x. So then we could substitute that -7 in and see if we get a true math statement. So we would have, you absolutely don't have to do this, but just to make the point of the first little statement there, 63 minus 8 is 55, which is true. So we know that the answer is -7. You don't have to plug it back in, but as we get further into Algebra 2, when we get to Unit 4, you will have to substitute stuff back in. Okay, so example 2 here, I'm going to start by combining like terms. 5g, -7g, and 4g gives me 2g plus 18 equals 8. Subtract 18 equals -10, divide by 2g equals -5. Again, you do not have to show all your work if you can do this in your head. As long as you're doing it correctly, and like this would be on a no calculator part of the test, and so if you can do it in your head without a calculator, fantastic. Okay, these next ones we got to distribute, so -6y plus 12 plus 20y minus 32. Combining like terms, 14y minus 20 equals 92. Add that 20 and divide by 14. And I believe that is it? Oh gosh, my brain, and I left my calculator out there. I should be able to do this in my head. Is it 8? 112 divided by 14, I believe, is 8. Yes, it is. Okay. So number 4. Distributing again. Okay, there's lots of ways to distribute a fraction. What I do in my head is I multiply by 3, divide by 5, so that'd be 45 divided by 5 is 9. You could also do 15 divided by 5 and then times that by 3, however you see it. So I'm going to do 3 times 20 divided by 5. Over here, I'm going to do -1 times 18 divided by 3. -1 times -12, divided by 6, which gives me 3. -1 times -12 divided by 6 gives me 2. Combine like terms. Subtract 14 and divide by 6 to get d equals 4. This should be review. This is a skill from algebra, so you should have done that in 8th or 9th grade. Distribute 2x plus 20 equals 2x plus 5. Okay, so I didn't say this up top. I just kind of jumped in, but I don't think it came up even. When I have variables on both sides, at this point you're just combining stuff, so you can do whatever you want. But when I have variables on both sides, I like to combine the variables first. And the reason I do that is because now I'm left with 20 equals 5, which is not true. So this has no solution. I did not have to combine the variables first. I totally could have subtracted the 5, and I would have had 2x plus 15, subtract the 2x, and I still get 15 equals 0, which is not true. By moving the variable first, you can just see it took me way less work, took me less steps. I still got to the same answer, but I like to not have to work so hard. And so I choose to move the variables first to combine variables, and then it just saves me work in the end. But as long as you get to the answer and it's legal, not cheating or copying, I support it. Okay, example 6, distribute that 4, negative times a negative. Watch those negatives as you move up into higher math. You start to have lots of steps, so there's lots of opportunities for little mistakes, and those are the things that get us. So if I look at this, I can see that everything's the same, so I know the answer off the top of my head, but pretending I don't, I'm going to combine my variables here, and I get 24, which equals 24, which you could put infinite solutions if you'd like, or you could put all real numbers. I will accept either answer. They are the same thing. Okay, you could also do a double-lined R, which means all real numbers as well. Okay, one thing I want you to notice, these are called special cases when we have no solution or infinite solutions. And when we have that, notice my variables went away. There's no longer a variable in my solution. And so that's one kind of clue for you that, okay, it's going to be a special case, no solution, or infinite solutions. All right, solving inequalities, we're going to do the exact same thing. I'm going to solve it like it was a equal sign. So I'm going to add 8. M is greater than negative 4. So I have this number line here. I'm going to put a couple numbers on there. So if you remember from algebra, or even geometry, when I have a less than or a greater than, I'm going to put an open circle. Okay, so at negative 4, I'm going to put an open circle, and then the numbers that are greater than negative 4 are these numbers to the right. If I have a greater than or equal to or less than or equal to, we're going to have a closed circle. So when we started this, I said a solution is what makes a true math statement. So if I have an open circle here and I plug in a negative 4 back into the equation or inequality, I have negative 12 is greater than negative 12. That's not true. Okay, negative 12 is equal to negative 12. So that's the difference between an open circle and a closed circle. This open circle says, hey, everything bigger than negative 4 would make a true math statement. So if I plugged in a negative 3, negative 11 is greater than negative 12, so that is a true math statement. I could plug in 0, negative 8 is greater than negative 12. Those were all true math statements, but negative 4 did not make a true math statement, so that's why it's an open circle on negative 4, because negative 12 is not greater than negative 12. If I was to underline this to make it equal to, then that would be true, so then we could color our circle in, meaning negative 4 is included. So hopefully that's review for you, but if not, there's a little explanation as to why open and closed circle. Okay, here I'm going to divide by 6. R is less than negative 6, so put some numbers on my number line. And this is a less than, so I'm going to have an open circle, and the numbers that are less than go to the left. Okay, same thing. Add 15 to give me 36. Divide by 4. So notice now it's less than or equal to. So I just like to put like 3 numbers on the number line. I am trusting in an honors algebra 2 class, you can put numbers on a number line. And then I did a closed circle because 9 would make a true math statement if we plugged it in. And so we can include it so we can color in that circle. Okay, here we need to make a note. If we multiply or divide by a negative, the inequality flips. Hopefully you remember that, but if not, here's a little note. Okay, so now I have to multiply by that -4. And so because I did that, my inequality is going to become a greater than or equal to positive 28. So I put my number line on here, color it in because it's equal to, and then we want the numbers that are greater than. Okay? Our buddy Keith has $500 in savings at the beginning of the summer. He wants to have at least $200 at the end of summer. He's going to withdraw $25 per week. How many weeks can Keith withdraw money? So when we define a variable, we are saying, what does our variable mean? So if I look at the question, we want to know how many weeks can Keith withdraw money. So I'm going to say X is the number of weeks. We are starting with $500, and then we are withdrawing $25 per week. This per lets me know I'm going to multiply, and at the end I want to have at least $200, so I want to have more than or equal to $200. Okay, go ahead and solve. I would subtract 500 to get a -300. Okay, I'm going to divide by a -25. So as I'm doing this in my head, I know I'm talking about time and money, so I'm kind of watching my positives and negatives. Can I have negative time? That kind of thing. Again, I divided by a negative, so I got to flip my inequality. And if I had, I believe that's 12. Okay, so Keith can withdraw money. You could say for up to 12 weeks, for 12 weeks or less, however you want to write it so that it makes sense and I know that you understand. Okay, so that was your review. I feel like I went a little fast, so if I did, please pause and rewind the video. If not, then do your homework and we will discuss any questions tomorrow. Thanks.